All right, guys. So we are on 9.2. This is the second part. So we're on to dilations. So this is the only transformation that is not a rigid transformation. Okay, meaning that after we find out what the image is not going to be congruent to the pre-image. Okay, so for dilations, something is getting bigger or smaller. If you look in our example, we go from the pre-image to the image. This one's getting smaller. Okay, so the vocabulary we use is we say the enlargement, meaning the figure is getting larger. So there's actually the word large and enlargement. So it's getting larger, it's getting bigger. Or the reduction, okay? The reduction. So that means it's getting smaller. So the scale factor. So remember, scale factor is just a simplified ratio or fraction of the corresponding sides. All right, so the scale factor indicates how much the figure will enlarge or reduce. So that's what we're going to have. Now, the variable we use for the scale factor, which you're going to see a lot in the problem, is k. All right, so they're going to tell you, hey, k equals 5, k equals 1/3, k equals 2, k equals 1/7. All right, so basically what they're saying is that when k, all right, when the scale factor, whatever that number is, if it's greater than 1, because it's not going to be 1, because if it's 1, it's going to be the same figure, okay? If it's 1, that means the figure didn't get bigger or smaller, and a dilation is something where the figure is getting larger, getting an enlargement, or a reduction. So for this, if k is greater than 1, the dilation is an enlargement. So that means the image is going to be bigger than the pre-image. Now, if k is less than 1, meaning a fraction, all right? So here, this means that we're going to have a fraction, all right? So k is greater than 1. That means k is going to be a whole number, all right? So a whole number. So if k is a whole number, it's an enlargement. If k is a fraction, then it is a reduction, okay? It is a reduction. So for this, information is very important when we're solving problems here. So number one, I have set up for you guys with triangle RST with vertices R, S, and T. So how we're going to solve problems like this, and it's not too difficult. All right, it tells us is that k is 2. K is our scale factor, okay? So all we're going to do for this is we are going to multiply the coordinates by the scale factor. All right, so we're going to multiply coordinates by the scale factor. That's the important part of this. So triangle RST has vertices, and I graphed it there, -5, 1. So let's start with R. So if we're going from R, which is at -5, 1, all right, and we are going to R prime, and we're trying to figure out what R prime is going to be, okay? What we're going to do is to figure out the X and Y coordinates, we are going to take R and multiply those two coordinates by our scale factor. And in this case, our scale factor is 2. So we're going to do -5, all right? And we're going to multiply by 2 to get -10. Now, we are going to take this 1, all right, multiply it by 2, and we're going to get 2. So now our coordinate for R prime is at -10, 2. Okay. Now, if we move on to the next one, okay, the next one. So our next coordinate is, let's see here, S, which is at -3, 4. So we are going, so S prime, same thing again. We're going to multiply by 2. So that becomes -6, multiply by 2. So that becomes 8. So our coordinate for S prime is -6, 8. All right. And for the last one, T, it looks like we're running out of time on this video. So we'll finish up T in the next video.